Hello everyone. In this video, we will be discussing about some of the advantages, disadvantages and applications of chemical machining, and even the process parameters also we will be discussing. So this is like very important video because in examination you people can expect like these kind of questions. So first we'll start with the advantages and disadvantages of the chemical machining. So the advantages of chemical machining process does not distort the workpiece and it does not produce burrs and it can easily be used on the most difficult to machine materials. You can able to see this compared to any other non-traditional machining process. The major drawback or like the demerit what you would have observed in all the non-traditional machining process was the machining setup, the capital investment, the maintenance and other things. So overall it is an expensive process, but compared to the like a chemical machining process, even though it is a non-traditional machining process, it is not very expensive. So, but in case of the chemical machining, where this is not a thing, because compared to any other non-traditional machining process, it is not very expensive. And even the chemicals, whether it is a maskant or the etchant, what we are using for the machining, it is also not very expensive. And one more benefit is it can be recycled. So, but the major drawback I could call it as the process, it is very slow, and so that is why it is not usually recommended for the large quantities or the machine a material which is thicker than 2 mm. Even though it has its own demerits, but it can be widely used for some of the applications where if you are looking for the working operation cost and even the effectiveness and other things, so this is recommended. And even some small parts are also made, that is 10 to 100 at a time on a single plate, which speeds up the production. And moving to the applications where chemical machining is used in the aerospace industry, mainly to remove shallow layers of material from large aircraft components, missile skin panels and extruded parts for airframes. And even chemical machining has been applied in a number of usages where the depth of metal removal is crucial to a few microns and the tolerances are also close. The surface finish obtained in the process is in the range of 0.5 to 2 microns. Besides, it removes metal from a portion of the entire surface formed, which is regularly or irregularly shaped parts such as forgings, castings, extrusions, or the formed rod stocks. And one of the major applications of chemical machining is in the manufacture of burr-free integrate stampings. And the next is about the process parameters of chemical machining. Like in the previous process parameters, we would have widely understood what is this process parameters. It may be like surface roughness, metal removal rate, accuracy and all those things. So generally, if I can speak about all these things, means if I am going with any of the non-traditional machining process, so what would be the efficiency? So whether I could able to achieve the metal removal rate in the stipulated time. So say for example, only one setup is available and I'm just looking for like 100 different parts within an hour. So is it possible with only one machine, or else like if it is a mass production, the same thing is applicable. And next one is accuracy. Whatever the sketch which I have designed either manually or by using the computer softwares, whether I can able to recreate it as it is. So and like that, and even the in case if it is a material related or like a current related or like some source related, means whether it could be able to get the expected range. Expected range means usually like we'll be talking about the profits, or else sometimes the life, sometimes maybe the usage. So based on all these things, the process parameters will be discussed. But in case of the chemical machining, since we didn't have much the major parameters, we will be going with the three basic information, that is material removal rate, accuracy and the surface finish. So first we'll start with the material removal rate. The material removal rate is mainly dependent on the selected etchants. So but the etchants, whatever we are using for removing the metal, which fasters tend to have many side effects, including a reduction in surface finish, increasing undercutting or higher heating or greater chance of etch rate with temperature, and attack on the bond between the mask and the workpiece. So these are all the some of the problems what we usually see. The higher heating might lead to the high stressors and which can have an impact on the strength of the material. Uncontrolled rate of material removal rate can lead to problems which can affect accuracy and surface finish. The material removal rate should not be very less as it takes more time for machining. So more time in machining affects the production rate and the cost per piece may increase also. And moving to the etch rate, which is generally limited to 0.02 to 0.04 millimeter per minute when surface finish and accuracy are not important. The etch rate as high as 0.1 to 0.2 millimeter per minute have been achieved. So although these penetration rates seems to be low, but overall metal removal rates are quite high. In an aircraft industry, the metal removal rate on an aluminum is reported to be about 140 centimeter per minute. Moving to the second major process parameters, that is accuracy, where machining is done to your workpiece for a better accuracy of the element, and it is also very important to know about the range of accuracy of your process before implementing it. So here we will be looking at a few materials and their accuracy range if this procedure is utilized. So the main factor affecting accuracy is undercut. So while designing this factor, this factor has to be kept in mind, giving it its allowance for respective alloys. So maximum taper, particularly when produced by slow immersion or withdrawal rate, is usually like 0.08 mm for 100 mm depth in steel and 0.08 mm in aluminum alloys. And sharp radii cannot be produced in the cutting direction. So the other factors affecting the accuracy is material removal rate. So if the rate is optimal and higher accuracy can be obtained. There are other ways also to improve the accuracy. So with the help of electrochemical machining, the rate of accuracy is increased. And further developments have lead to laser assisted chemical machining, and by using precision process, so we can achieve new levels of accuracy and repeatability with etched channel like featured size in the region of 25 to 30 microns with the tolerances generally around a plus or minus 10% of the material thickness. With the help of the photochemical machining, a part of size 0.5 mm can be achieved also. And the last process parameter, that is about surface finish, where initial surface waviness and the defects are not greatly altered in contouring most metals, but may be smoothed out to a certain extent. The quality of finish is lower for extrusions, forgings and castings. The surface finish uptime may be around 5 micron meters, but aluminum alloys show better surface of the order of 1.6 micrometer, and hydrogen embrittlement may occur owing to the absorption of hydrogen in chemical machining in some metals, and aluminum alloys are not subjected to hydrogen embrittlement. So considerable care should be taken to avoid hydrogen embrittlement in steel, stainless steel, copper alloys and nickel alloys. If hydrogen embrittlement occurs, it can be overcome by heating the workpiece to 1200 degrees Celsius for 1 to 4 hours. Then the surface provided or the surface produced by the chemical machining process are otherwise stress free, and we can show no thermal effects. And surface finish depends on surface quality of original workpiece. On most materials, scratches and local damage will be reproduced and magnified. Chemical milling removes small defects or scratches in magnesium and to some extent in steel and titanium sheets. So this is all about the process parameters of chemical machining process. Thank you.